Okay, so what are phase shifts? And the best way I want to do this is let's look back at kind of other functions and how we kind of shifted them. And I was kind of helping some other students here in my Algebra 2 program. I was work with them, and they're like, oh, this isn't bad. When are we going to use this? And well, here's an example in trigonometry where we're going to use it. So let's just let's just use a standard quadratic here. So here I have a parabola, and the standard form equation of this is y equals x squared. And then what we talked about is if I was going to now say, well, what happens if I make a graph? And actually, let's use a little color coordination here. What about if I now said, y equals x minus 2 squared? Well, by using our definition of transformations and translations, we now know that my graph is going to be shifted 2 to the right. It's going to be the exact same graph, just now transposed over 2 units to the right. And if I was going to do another alteration with that graph, which we're actually not going to work with this, but let's say if I wanted to say y equals x plus 1 squared, well, what that meant is now I'm going to shift my graph, exactly the same graph, 1 unit to the right. And these are what we call our horizontal shifts of a graph. And we also have vertical shifts of a graph, but what we're concerned about right now is our phase shift. How can we move the graph left or right? And it was important for us to understand why we did the opposite direction, because when we look at the standard form of a quadratic, the standard form of quadratic says y equals a times x minus h squared plus k. And this is very, very similar to our trigonometric function we're going to use. And it's noticed that you can do the x opposite of h. So therefore, when I say x minus 2, that means I'm going to be shifting the opposite to the right 2 units. So this is a little review, a good review for us to understand our phase shifts. So to understand the phase shifts, let's take a look at our standard form of our sine and cosine graphs, because that's what I want to focus this video on. So I have y equals a times sine of bx minus c plus d. And I did want to put the sine in there. And let's do y equals a times cosine of bx minus c plus d. All right, so now it's very important for us to understand that we have that minus c again. Just like the x minus h, we have the minus c. So therefore, if we're dealing with a subtracted number, that means we're going to be shifting to the right. And if we say a positive c, that means we're going to be shifting to the left. Now, how far are we going to be shifting? So here's where I usually like to start off with my students. I say, all right, let's do a general equation, y equals sine of x minus pi. All right, and we kind of get to this and you say, oh, well, now you're going to shift pi units to the right. So what we'll do is we'll take our whole trigonometric graph and you're just going to shift it over pi units to the right, and then you graph it. But then I always get students when I start transforming like this, and I say cosine is going to equal, let's say, pi x plus pi. And they say, well, that means now shifting to the left 1 unit. And that's correct from what we've learned so far. But it's important for us because now when we're not just talking about taking a function and shifting it left or right. But remember, our trigonometric functions are cyclical. They keep on repeating on and on. And there's a very important part that's a part of the trigonometric functions, which is the period. And what that says is, the distance, how long it takes for a function to go over and complete one revolution or to repeat itself. And that period affects our phase shift. And remember, to determine the period, we had to look at our b. And so when we have a value of b, that's going to affect how we're going to shift our graph left or right. So for this function, let's go back to our original function. And on our original function, we said, it's going to be 2 pi divided by b. So 2 pi divided by 1, which equals 2 pi. All right. However, for the cosine function, when we look at our period, we're going to take 2 pi divided by pi, which means now we're going to have a period of 2. So rather than it taking a distance of 2 pi, it now takes a distance of 2 for this graph to repeat itself. So how are we going to determine what the phase shift is, how much the graph is going to shift left or right? So what we do is we do the initial period. And you're going to see me do this on all of my videos. I always like to graph the initial period. And I know, and I don't want to be confusing with this because graphs are cyclical. They repeat on and on in the positive and negative direction. But our parent graph, when we look at the parent graph, we look at the initial period, meaning kind of like the first period we could graph. And once we have that first graph, we can repeat. So by looking at the initial period, we need to understand where does the sine and cosine graph start and end. And both the graphs start at 0, and they also end at 2 pi. Now, that can change, though, depending on the period and on our phase shift. So we could say that each graph always starts at 0 and always ends at 2 pi. Now, if there is a transformation, though, that's going to affect our initial period. Now our initial period is going to start and end at different points. And what that's going to help us is when we find our initial period, that's going to tell us where our phase shift is. So if it, rather than our graph starting at 0, if it starts at somewhere different, now we know exactly what our phase shift is. So let's do that for this graph. If I wanted to find the phase shift, rather than just saying, oh, it's pi to the right, let's do x minus pi equals 0. Now, when you add pi, what you notice is you get x equals pi, which tells us we shift our graph pi units to the right. All right? So you're always going to take, when trying to find what is your phase shift, take whatever's inside your function and set it equal to 0, because that's your initial starting point of your initial period of your parent graph. So let's go and take a look at this one. Why is this not shifting left pi? So I take my function, which is pi x plus pi, and I set it equal to 0. Now, by solving for x, I subtract pi on both sides, and I get pi x equals negative pi. Divide by pi, and I get x equals negative 1. So now you can see that my graph, when I graph this, rather than saying, oh, remember, the sine function, we start at 0, then it goes up. Now, or the cosine graph, we say, oh, it starts at 0, goes up to negative 1. Now, that graph still is going to start at negative, or still start at y, the y value of 1, but now the x value is going to be negative 1. So what that means is now I'm shifting, this graph has a phase shift of 1 to the left. So there you go, ladies and gentlemen. That is a definition of phase shift for the sine and cosine graphs. Thanks.